This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Okay, so let me introduce myself. My name is Piotr Stapp. It's quite easy to remember. There's a quite famous song, "Don't Stop Me Now." You just change 2 letters and everything works. I'm Microsoft MVP by night. By day, I'm working as a principal safe system architect in demand in cloud area. I'm almost a cyborg. I'm wearing a hearing instrument. I have some titles. That's all. Today, we'll be talking about the real cases from the demand, and not only demand, about how we optimize cloud in a longer perspective, what you can do, maybe how can I inspire. But before we start, offshore recommendation for Microsoft Azure, because we are mostly operating on Microsoft Azure, there are almost 5 links. Starting from Azure Pricing Calculator, Azure Cost Management, Azure Advisor, TCO Calculator, and Azure Hybrid Benefit Savings Calculator. So as you probably can guess, there's a lot of stuff that you need to know before you even start to optimize your cloud. Anyway, I recommend the first one, and the rest is, okay, the second one for sure, because you are looking on what you are really need. But to be honest, the main principle behind optimizing cloud is you, or me, or everybody. Because it's not so easy, and the offshore recommendation, or let's say long-hanging fruits, are easy to achieve, but the biggest savings are somewhere else. So, probably, especially Polish-based people recognize this quote, because that's exactly how we need to work. If we replace theory with the FinOps, so FinOps is when we know everything but nothing works. Practice is when everything's work and no one knows why. And in this room, we combine theory with practice. Nothing works and no one knows why. So the first story, because to think about the cloud optimization, you need to first build something. Newest buzzword in the IT is platform engineering. So everybody is building a platform. It's not good, not bad, but in our case, the platform contains the hosting, so Azure Kubernetes Service. What else can we use? Plus container registry, plus a lot of stuff more. As databases, both Cosmos DB, storage, and Azure MS SQL and storage, mostly Cosmos and storage. The rest, so for the test and monitoring, Azure Cloud Testing, Availability Test, Log Search, Azure, Smart Detector, Azure, and much, much more. And in the end, of course, we have a lot of Azure infrastructure, starting with keyboard, managed identity, networking, blah, 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 blah. People say it's simple. But from the, let's say, process perspective, we have following environments. We have a typical dev environment, we have a test environment, we have, of course, a load test environment, but we use this environment with the test environment. We have a pre-production and production. Probably in most IT projects, it looks more or less the same. Sometimes people have only production, but in the high regulated environment, you cannot use only production. So, moreover, maybe one more thing. When I was on university, people say that that's the best option. But from the cloud perspective, if you think, you need to pay for all 5 environments. That's why we are reusing test with load test environment. But there are more problems. As a general rule, in the testing, let's say the statement is that the test environments should be as close to production as possible. Yeah. We have more test environments than production. So what's the result? Each test environment costs almost the same as production, of course, without the usage. Yeah, and for the most time, test environments are idle. There's nothing there because we are working on the dev environment, then we test something for 2 days, and then for half a year, it's just idle. So theory versus practice, to work or not to work, that's the question, as William Workspear claimed. So for the non-production environment, typical usage is from Monday to Friday, except weekends sometimes. But okay, without joking, we are in the bets for sure. It's from Monday to Friday, usually from 9 to 5. Okay, we can say from 7 to 7, yeah, from 7 a.m. to 7 p.m. So because some guys love to start working early, some of them want to start working late, and so on. But in the results, we have 5 days multiplied 12 hours plus some random, yeah, because we need to do something. So we have more or less 60 hours instead of 7 days multiplied 24 hours. So it's 168 hours. So for 100 hours or 64% of a week, machines are idle because no one is working there. That's a real diagram. As you can see, you probably can guess Sunday and Saturday. As you can see, there are exceptions, of course, during the load because, for example, on the September 11, we ran quite huge load testing just to test something during the weekend when everything is idle. But more or less, it's 64% of the week. There's nothing there. That's why we are turning off our environments. What about, yeah, because that's the easiest way, yeah? So for the 64% of the time, just turn off the environment, and that's the result. What about 24 hours per 7 days? Of course, you can choose wisely your virtual machines or anything that is using virtual machines under the hood, starting with databases like Cosmos or normal databases like MS SQL or even Azure Service Bus or whatever. There are a lot of types of virtual machines under the hood: general, memory optimizer, boostable, and much, much more. But if you allocate them for a longer period, you can use 2 things. You can use reserved instances for continuous runs without changes, or a saving plan for dynamic workloads with a different size virtual machines. And as you can see, there's a huge discount, especially in reserved instance for 3 years. It's almost the same as idle time of our environment. So what we should choose? Reserved instances or shutting down the environment for the period. But there's more. When we think about the cost in Azure, there's amortized cost versus actual cost. Amortized cost shows us the raw usage and purchase from Azure and third-party marketplace offering, and amortized cost brings the reservation through the time. So when you compare the actual cost, yeah, that's the actual cost, and for the same subscription, for the same resources, that's the amortized cost. The reservation is just added to the diagram so you can see what's going on, even if you pay upfront for 3 years. So why turn off instead of reserving? First of all, because not all the resources can be reserved. Moreover, then dev environments are not stable from the cost perspective. When dev teams are working on the product, of course, there's a huge usage here. When they stop because they change the product, change project or whatever, there's an idle time at all. And running workload, because the savings which I presented are only applicable for the virtual machines, but we forget about logs, database operations, data transfers, and much, much more, which usually cannot be reserved. So that was the first case. And the first lesson learned, turn off if you don't need it. The second thing is about the Cosmos, because Cosmos DB is usually a really very expensive resource, but you can make it cheaper. For example, that's the actual cost of our Cosmos DB for 2 months, as you can see, November and December last year. And we try to optimize it because, as you can see, it's okay. It's not a high because it's development environment, so it's still okay. The standard optimization in the Cosmos DB, you need a PhD to know all the rules which you can use to optimize Cosmos DB. Okay, maybe not PhD, but I called it a PhD in Cosmos because you need to spend at least 2 days to understand what options have, okay, maybe different options have a totally different consequences based on the way how you try to use it. That's why it's expensive resource, because most of the people don't use it in a proper way. So if we talk about the typical account, for example, if you use a multi-region write, you need to multiply the arrows, which is a virtual something resource unit, which Cosmos charge you for the usage, which combines CPU and memory and the transfer and something. With multiple regions, if you would like to have availability zones, because availability zones are good or not. But a minimum is 4,100 arrows in the manual standard. But if you go to the autoscale, it starts to be fun, because autoscale, when you look, it's multiplied by 1.5. So it's more expensive, isn't it? Of course it is. But there's a small but. When you use a minimum 40 arrows because you need to multiply it by container, in autoscale, you don't have to. You have as many containers as you want. So if you have more than 6 containers, it starts to be cheaper to use autoscale, even if per container, it's a cheaper option. Because a minimum of 100 arrows is needed. Okay, so that's fun, I think. I'd recommend you, if you want to use a Cosmos DB, just try to look what's going on, especially that official example can see us that if we use autoscale, for example, for 6% of the time, you can see the numbers. I won't read them aloud, but you can see the savings of 39%. But in our case, it's even better because we are using a lot of collections in one Cosmos DB account. So we, instead of paying for each container, we are paying for the whole database. And as you can see, that's a real example. If we are using a manual scaling with 1,000 arrows, we need to pay $175. And what's funny, and that's a new thing, and I still don't know why, because the official documentation say, okay, in the official documentation, it's written that it should be multiplied by 1.5, but I checked it today, and as you can see, there's no difference. I don't know what happened, but that's okay. Who cares? But there's another option which is available for the Cosmos DB for the more or less 1 year, that you can use a serverless option. So you are paying for the arrows based on the usage, not based on what you would like to reserve. And for example, if you would like to use 1 million arrows, and of course divided by 1,000 to get, so you have 1,000 hours, so with this 41 days. So serverless can be cheaper if your usage is quite low. Which starts to be crazy, but serverless doesn't support available high availability. So you cannot have the serverless in the multiple regions. So depends on where are you and which environment you are using, you can choose which option is the best, but only based on the usage and knowing the documentations. Moreover, it's not the end, because indexes are hard, as always. Especially that in most, let's say, when someone applies a job, the main question is about the indexes in databases. Still, we don't apply this knowledge in production. In Cosmos, everything is indexes, is in the index. Everything, each field, until you exclude it manually. So it costs a lot. Yeah, that's obvious. So a small change in indexes, as you can see, can really change a lot in the costs. Okay, I will say 50%, 40%, just changing the indexes which you are not using. You reduce the amount of errors. The same, of course, applies to any other database in the cloud. If you change the indexes, that's an example from my, let's say, home stuff. I made a mistake, as you can see, there was 100% of the usage. Then I changed the indexes one more time. And after that change, my database was working quite well. So optimizing indexes still is a silver bullet. Let's rewind a bit. As you can see, there's a huge difference between this region and this, time period and time period. What happened? Again, nothing spectacular. We changed the backup policies because you could have a periodic, continuous, and continuous for 7 days and continuous for 40 days. And let me explain. The periodic means that your backup is taken at periodic interval, for example, each 2 hours. And only 2 last backups are stored. Sounds good. You can choose, let's say, once per day or 2 per day, and 2 last backups are stored for free. To restore the backup, you need to write to Microsoft support, so they will do the action for you. Awesome. And only 2 backups are available. For continuous, you have access for each point of time, maybe each 5 minutes in the last 7 days. So you can choose the point of the time and restore the database from exactly that point of time. Awesome feature. So let's compare the cost. So if, again, our example, 2 copies, 3 copies, as you can see, cost something per 100 gigabytes, $12 as far as I can see. And if you think that you would like to have a backup for each 4 hours, having only 2 last backups, it's a really could be a real problem. But let's change to the continuous mode. So the continuous for 7 days, it's free of charge. The 30 days, sorry, I didn't change the slide. Currently, you need to pay, but for 7 days, it's free. So you have a better backup for free because they introduced a new feature which we didn't spot in the, let's say, in the proper moment, and we paid for 1 year. For worst backup, we pay a lot of money. So, and that's the magic happens. We just changed the switch in the portal, nothing more. As you can see, it's quite funny. So let's use serverless, because serverless is the best way to utilize the cloud. Our architecture is quite simple. It's called Godzilla. It's for the log storing. As you can see, we have long time ago, 3 years ago, we have more or less 4,000 events per minute. So it was 75 per second. Then we duplicate them. Who cares? We have a huge change in May. As you can see, we have much more events, but no one cares. Then we have a huge change in September. So we start to have, instead of 9,000, 16,000 events, and so on and so on. That was the result, because one day we need to migrate from Azure Data Lake version 1 to Azure Data Lake version 2, and the cost exploded. We changed the tier in Azure Data Lake, and we have much more incoming events. And then we fixed it. Because as you can see, there's one day when there was a backup restore, which is not important, but we fixed it. To do that, we changed the architecture somehow. Exactly, we used this JSON file for Azure function, and the magic happens exactly here. We use a minimum event batch size and maximum batch size. We calculated, guessed how big the batch sizes should be, and we added wait time. So if only one event comes to the queue and it won't be stored for 1 minute, the trigger will be involved, so the event will be stored. But what's the biggest change here? I will go through the slides. Because in the previous architecture, we almost saved events on Azure Data Lake storage on every event, because we were fast enough. Each operation costs, I don't remember how many cents or microcents, but when you calculate the huge number of events, we need to multiply it a lot. When we add the idle time, instead of writing each event, we are writing more or less 1,000 events per once. So we optimized how we save events. But we have 1 minute more delay in data lake. In our case, it was acceptable because we don't process events, let's say, as a stream. We process them later in Databricks as batches for 1 hour or even bigger. So when we are talking about the processing this data, we are using Azure Databricks, probably nothing more. So how to optimize Azure Databricks? Because still we have a lot of events to process, prepare reports, in the end have Power BI. We asked Microsoft, hey, Microsoft, can you help us? Because we have, about reserved instances, we could use reserved instances because when you are running 24 hours per 7, you could have up to 40% or 62%. But there's a small problem. You are running up to 4-6 hours a day. We don't need more. We are, let's say, we are fast enough. So, and of course, we asked Microsoft, hey, Microsoft, could you please, we are a huge customer, could you please help us? We use reserved instances. We just apply, we just multiply the values and say, why we need to pay more? Oh, that's your problem. Maybe you will process more one day. Okay, sorry. So how to optimize? There's a huge, in each cloud, because it's applied in each cloud, there's something that's called spot instances. These machines can be evicted, or cost more, depends on the, let's say, depends on the action you choose. But this machine could be taken from you by the cloud provider. So they are really, really great for the, let's say, processing stuff, because if you lose this machine, you will repeat the processing, nothing will change. But, okay, I won't suggest to use it for the production services, but for the processing, it's really, really good. And there's eviction policy. You could stop, deallocate, or delete, and eviction type, you could capacity only, so your machine will be evicted when Azure say, we cannot support you, or a price or capacity, so the price will be higher. And when you look on the costs, you can preview the cost of the spot VM. You could see that it's much, much cheaper than a normal virtual machine. So I think I'm almost in the end. Yeah, I'm in the end. Okay. I hope you like this presentation. As you can see, there are no, okay, it looks like that we have a lot of low-hanging fruits. That's totally untrue, because the solutions were easy, but finding them out was really, really hard. Do you have any questions?
I am ready with the mic.
If you would like to link the QR code show About Me page, you can find me on social media or whatever. If you have any questions you want to ask here, you can always use a social media account.
And this is what I think we'll do, because I see no questions in the room. So thank you so much, Piotr, for joining us today. Round of applause for Piotr.